Hello students, today we are learning about a new function called a cubic function. And so we are going to begin by creating the graph of our new function. So look at the cubic parent function equation, and we are going to plug in some x values so we can get a good idea of what this graph is going to look like. So when I plug in -2 in for x, -2 cubed is -8. Because -2 times -2 times -2 is going to give us a -8. All right, when I plug in -1 and cube it, I'm going to get -1. Plug in 0, plug in 1, and plug in 2. Okay, now go ahead and graph those points so you can see what our new function is going to look like. And I have -1, -1, -2, -8. Okay, go ahead and connect your points. And you should get this little squiggly looking graph. This is called the cubic function. And we have a very important point here. This little point where the graph kind of turns, this is called the point of inflection. It's very similar to the vertex that you have had in other functions. But we call it the point of inflection because it's the point where the graph changes directions. So it is a very important point for cubic functions because it kind of operates like our vertex when we do transformations. That is the point that is going to shift around for the those two h and k points. All right, so now let's look at some features for this. The domain of this function, notice it's going all the way left and all the way right. So it is representing all of the x values. So it is from negative to positive infinity for the domain. And notice the range is all of the y values are also going to be represented. So this is also all real numbers. All right, we have an x-intercept. It is crossing the x-axis one time at 0, 0. That also happens to be the y-intercept. We already talked about the point inflection. It also is at 0, 0, but that is going to move around when we get away from the parent function. Our solutions, zeros, and roots, remember that also is where it is crossing the x-axis. So our solutions, zeros, and roots are also 0 for this case. All right, so today our goal is going to be using our transformations equation. What happens when I plug in numbers for k, for h, and for a? How is the graph going to shift? Well, since we've studied many of these functions this year, you know what the transformations are, and they move the same just like the other functions. So k is going to shift the graph up and down, just like it has for all the other functions. H is going to shift the graph left and right. Of course, we are going to remember that h is a little bit different. It moves the opposite because of this minus sign right here. And remember that a tells us if it is negative, that is going to be reflected. Keep in mind, for this function, when it reflects over the x-axis, think about folding this paper in half. What would the reflected graph look like if I was going to fold it? Well, this piece right here would be reflected down here, and this piece would be reflected like this. So when it reflects, it's actually just going to change the squiggle to be squiggling the other way. I call it the cubic squiggle. It's not technically a math term, but that's just what I call it. All right, so A also can, remember, stretch vertically or compress, which will make it a little bit fatter of a squiggle. All right, so let's talk about some transformations for this function. Even though this is a cubic function now, the transformations will work the same. So this negative will make it reflect over the x-axis, and this 5 will make it shift to the left 5. All right, let's just talk through the rest. This is another reflection. Remember, when it's less than 1, this will be a vertical compression of 1/5. So this is a vertical compress. It'll be a fatter squiggle. And this, notice, is outside of the parentheses, so this will shift the graph down 4. And the other ones you can follow along. The completed notes will be posted on Canvas, so you can go ahead and practice these transformations on your own and then check the key to be able to see if you got them right. But let's go down to the bottom here and talk about some of these other features. Sorry for the bell. All right, the x-intercept. If this graph is shifted, if I take this parent function graph and I shift it to the left 5, my new net x-intercept is going to be over here at -5. Does the reflection change my intercept? It does not. It just means it's going to squiggle the other way. Remember, instead of it squiggling this way, it's going to squiggle this way. So my new x-intercept is going to be -5, 0. We're just shifting it over to the left. For this one, remember we talked about this is going to shift the graph down 4. So if I shift my parent function down 4, that's going to change my y-intercept to be down here at -4. Remember, a compression and a reflection and a vertical compression will not change the intercept because it's not shifting that around. All right, the point of inflection is always going to be h and k. Just like it was the vertex for absolute value and quadratic functions, h and k will always tell us where the point of inflection is if my equation is in this vertex kind of form. So this point of inflection is going to be 4, -1. Remember, we always change the sign of the h when we write it out. So the point of inflection should be at 4, -1. So I can always just look at the equation like this point of inflection. Notice there's no h, so my point of inflection is going to be 0, +4. Because there's no h, I can assume a 0. Let's talk about one end behavior for these. I'm going to sketch a mini graph of what this kind of looks like. This is shifted up 4, and it is reflected. So instead of squiggling like the parent function, it's going to squiggle the exact opposite, and the 2 vertically stretches it. So it's going to look something like this. Not to scale, right? But this is a little sketch of what it would look like. So if I want to talk about the end behavior, I want to know what is happening at the ends of the graphs. So as x is approaching positive infinity, so on this side of the graph, the y's are approaching negative infinity because it's going down. Now let's talk about the other side of the graph. As x is approaching negative infinity, so as I'm going this way on the graph, my y's are going up. So the y's are approaching positive infinity. Had this graph be going down, I would just change that to a negative infinity. So all you're telling me is at the very ends of the graph, what is happening? Are the y's approaching positive infinity or the y's approaching negative infinity? So you're just going to be describing both sides of the graph, what's happening in the very ends. That's what it means to describe the end behavior. Okay, so let's graph a couple together. Looking on the back side of your notes. So first we're going to record the point of inflection. So on the graph here shown is the parent function, and this is going to shift the graph to the right 1 and up 4. So my new point of inflection is going to be 1, 4. So that's going to be the first point that I'm going to graph. I'm going to go over 1, up 4. So there is the new point of inflection. Now notice A is -1. So I need to reflect my parent function. So instead of it squiggling like the parent function, it's going to squiggle the opposite direction. So from my point of inflection, I'm going to go over 1, up 1, and over 1, down 1. So that when I draw the little cubic squiggle, it is squiggling the other way. All right, try one with a stretch now. Notice we have a point of inflection at 1, -1, 1, -1. There's my new point of inflection. And this time I have a vertical stretch of 2. The easiest way to do it is to always go over 1. Always go over 1 from that point of inflection. The A tells us where to move from there. So from there, I'm going to go up 2 and down 2 on either sides of that point of inflection. So for this point, I'm going to go over 1 up 2, and from this point, I'm going to go over 1 down 2. It is not a slope, so don't continue that pattern. That pattern only works for the first points away from the point of inflection. So, but you have enough information from there to be able to draw your squiggle. And remember, you can always create a table of values to be able to get more points if you need more points. But the idea here is just to be able to get enough information to get an idea of where the graph is by looking at that equation. You can get an idea of what it looks like. Okay, last one. Point of inflection here is at -1, -3. -1, -3. Based on H and K, I can see the point of inflection is going to be at -1, -3. This time I have a vertical compression of a half. So remember, I said always go over 1 from that point of inflection, always. A tells us how many to go up and down from there. So I'm going to go over 1 and up a half, over 1, down a half, to be able to draw my squiggle from there. Okay? Do not go over 2 up 1. That's what slope is, but this will not work that way. You can plug in some values in for x and test it out and see that does not work. Try plugging in some x values on either side and you'll see that is not how you do the next points, okay? Okay, the guided practice below, I would like you to do these on your own, and then you can check back on my key to be able to see if you got those correct. So go ahead and practice them on your own and see how you do.